Hello everyone, this is Professor Maloney, and today you see I got a fresh haircut. This is a new picture, a new recording, meaning recorded on November 21, 2022. I just cut my hair yesterday. Man, it looks good, I think. Yeah, it looks good. Yeah, oh yeah. So anyway, we're up to chapter 8. So congratulations to those of you that are staying current and that you've done a great job through the first 7 chapters of this C++ programming class. The last chapter in the class is chapter 8. So like I did in virtually every chapter since chapter 2 anyway, what I'll do is basically 3 videos. One video as an overview, what the chapter is about, and another 2 videos demonstrating some programming examples for that particular chapter. And I'm going to try to not give you as much on my programming videos as I perhaps sometimes do, because, let's face it, you guys have to read the chapter. You have to make sure you're understanding it. You need to go through the ebook. You need to go through your programming exercises. You need to go through, Google searches. You can go through the ebook, and the ebook at the MindTap site has lots and lots of examples in it for every chapter. And I mentioned the visualize sections off the MindTap website many times as well. And the visualize code is excellent too. All righty. All right. So let's get to it. Take me away, and I'm going to start by giving kind of an overview as to where we are. Okay, but I'm not going to have this one go crazy in terms of length. All right. All right, I'm going to share my screen. So hide this. Now we should get our little stream effect. All right, there we are. So over here now, what do I want to say? Yeah, I want to go to MindTap. I'm on the MindTap. Oh, let's see if I'm still here or not. I came on a long time ago. Let's see. Let's collapse all and see if I'm still here. Where am I? This is this is the first class, the 5355, Tuesday, Thursday, 10:40 a.m. All right, so let's go over here. So we're in chapter 8. All right, I'm going to start this time a little bit differently. I'm going to show you what these programs are all about. You see, only a couple of you have done the first 2. One of you has done the 3rd one. One of you has done the 4th one. 2 of you have done the 5th. One has done the 6th. All right. So what is the first one? Great question. Uh-oh. Let's get out of here. Maybe it was just dying. That's because of what it said. All right, so let me get over here. And on it, let me get here, here. And go to MindTap. Oh, shoot, I should make these bigger again. It is bigger, okay. All right, I'm going to go on over to MindTap. All right, so now again, going down to chapter 8. All right, chapter 8. I'll show you just for a second on visualize. So let's see. So programming example text processing. Text processing probably is going to be using a data file. I have not seen this, or I have not seen it, I should say, in a long time, but I've for sure seen it. And arrays. You definitely need to watch the one on arrays, but I'd also recommend that you watch the one on programming example text processing too. All right. All right. So in the code, I'm going to click on each one just to kind of read what you guys are going to be doing. All right, so I'm going to say start the assignment. Obviously, I'm not going to start it, but I'll just kind of read it. All right, so remember, this is the arrays chapter. Write a C++ program that declares an array alpha of 50 components of type double. Okay, initialize the array so that the first 25 components are equal to the square of the index variable, the position that element will occupy. So in other words, for the first 25 numbers, whatever those numbers are, we're going to square them. So times them by themselves. 0 times 0, 1 times 1, 2 times 2, 3 times 3, etc., up to 24 times 24. Because the first 25 they said, and it starts at 0, which means it'll go to 49. So from 0 through 24, that's what you're going to be doing. All right, multiplying the values that are assigned. Now, I haven't read any of this yet, but in any event, All right. And then the last 25 numbers, so that's going to be equal to 3 times the index variable. See, when it says index, the index is like the 0, the 1, the 2, the 3, etc. Okay, but the index variable means what value was put in that variable. So in the case of all 50 of these numbers, I'm going to pretend that the numbers entered are also the same as the index, 0, 1, all the way up to 49. So you'd basically multiply 0 times 0 for the first value in terms of what they're wanting to get 0. 1 times 1 would get 1. 2 times 2 would get 4. 3 times 3 would get 9, etc. That's how I'm going to start ending things, etc. You should be able to understand the logic that I just said. Okay, and then once you get to position 25, so because it's 50 and I'm saying I'm pretending anyway, I don't know officially what we're doing, but I'm pretending that we're going from 0 through 49. And I'm saying the 0 through 49, yes, they're the index values, just like programming always does. It starts at 0. But I'm going to also say that those index values are also the variable values. Okay, so when we get to the 25th one, then they want that value. So the position for 25 will be multiplied times 3 times 3. So starting in position 25, the answer would then be 75. And then for 26, it would be 78, because 26 times 3. For 27, it would be 81. And for 28, it would be 3 20s are 60, 3 80s are 24, so 84. Okay? And again, the first 3 or 4, 0 times 0 would be 0. 1 times 1, so it would be 1. 2 times 2 is 4. And 3 times 3 is 9. And that would carry on until 24 times 24, which would be 24, that's 240, 480. And 480 and what? 24 times 4, so 240, 480, and then you got to multiply the 4 times the 20, so 485, 60, and 4 4s are 16, 4, 560 and 16, 576 is probably the 24th value. But that's what we're doing, okay? And then here they're showing you an example of the output. So here's what your output should look like. So I'm not sure what numbers they told you to actually do then. Let's see. Output, okay. 25 components are equal to 3 times. Program output. Where do they tell you what to put in? Mission says the first one equal to the square of the index variable. Position that element will occupy, and the last 25. Well, either way, I'm going to just assume from 0 on up. But obviously, they're telling us, so here, 0 squared is 0. 1, okay, it is, yeah. See, 2 squared is 4, 3 squared is 9, 4 squared is 16, all right? So, and I said 576 would be 24, all right? Then the next one, so the 25th one, not this 25, but up here where I said we'd get to index 25 and also be value 25, they're only times 3, though. So 25 times 3 is 75, and the last one is 49. So 49 times 3, 50 times 3 is 150, less 3 is 147. All right, so that's what you're doing. So more or less what I said. All right, and that is, of course, what? It's an array. It's a one-dimensional array. It's pretty easy. You're just going to have it set up. Obviously, you're going to be using loops in conjunction with arrays. Normally, we do use loops with arrays. So you'd probably be doing a for loop or a while loop to make that happen. All right, okay, I'm going to get out of 8-1. 8-2, just again to show. So 8-2, we'll say start now. This is just our little warm-up, sorry. Okay, I mean warm-up meaning just to get going, but I'm going to hopefully not make this video more than an hour. All right, so here, C++ function, smallest index, that takes as parameters an int array and its size and returns the index of the first occurrence of the smallest element in the array. To test your function, write a main that prompts a user for a list of 15 integers. So you're going to have a COOT statement asking the user to enter 15 numbers. You're going to output the index and value of the first occurrence of the smallest value. So if the user enters, okay, so they're saying 15, right? So it starts at, well, enter 15. Okay, yeah, I was saying they didn't start at 0, but they have a 0 entered here. That's why it ends at 14. So really it's 14 because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But then there's the 0. Okay, so the 0 means then we actually have 15. Okay, so and let's see the position of the first that. Okay, I think they're saying this is, so if these were the input numbers then, So we're pretending the user inputs 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 10, 11, 12, 13, and 14. Then the position of the first index, the first occurrence of the smallest element. So the smallest element, it says, is in position 9. Okay, 9. So if you figure out 9, then you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 in terms of the way we normally go. But obviously, we're entering them. So technically, in terms of position, it should be 0, 1, 2, 3, 4, 5, 6, 7, 8. So let me see what the heck they're saying here. So 1 through 13, 14, 1 through 14, the position of the first occurrence of the smallest element in the list is 9. The position of the smallest element. And the smallest element, so the smallest element is 0, but the position is 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm not quite sure about what they're saying here, but in any event, so in my humble opinion, it's a 0, but it's the 8th value. 8th value. Okay, let me read this one more time. So smallest index takes as parameter an int array. So you're going to have an int for, smallest index, I guess you're going to be calling it. And its size, and returns the index of the first occurrence of the smallest element in the array. So the smallest element for sure is 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 0. Sorry, 0 is the smallest element. Yeah, so it's 0. So this one pretend is the first position. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 is 0. So they're exactly right. Okay, it's just confusing because of the 9, and it's the 9, but it's, yeah. So the 9th position and the element, the smallest element, is 0. Okay, that's perfectly fine. All right, so that makes sense. So that's, that's pretty easy. There are some examples in the book that show you that for sure. And I'm going to be doing a demonstration which will show quite a few things for 2 or 3 of the programs, but I'm not going to give it all away. I'm just going to do examples where I include things, and I'm not going to overly expand on what I've done. I'll just let you then go into yours as long as the programs, and hopefully you follow what I do in the practice example. And of course, because this week is Thanksgiving week, so this will be played in class on November 22. November 24 is a holiday. November 29 then will be the first programming example. So this is probably the one where I'm going to demonstrate 2 or 3 things off the chapter, and part of that off the chapter will cover little bits of this. Okay. All right. So that's 8.2, 8.3. And of course, these are all due December 9, right? Okay. So start the assignment again. And let's see this one. All right, write a C++ function. Oh, and of course I didn't mention, but so when we're using a function, obviously we know we're using something, we're creating a function, but we're definitely using an array. So last largest index that takes as parameters an int array and its size, and returns the index of the last occurrence of the largest element. This is what I just read. Maybe that was smallest. Yeah, smallest, because it was a 0. Oh, yeah, this is the same thing. 1 through 9, then 0. And remember, 0 is the smallest element. But they're saying largest. So I guess they want then the largest index. And in this case, okay, they got different numbers here. Okay, but these are like test X, I guess, to test your code. Yeah. But based on this, they're saying the largest element in the list is 14. And the position, and it's also 14. It's 14. They're saying both ways. Well, let's see again, because the other one, I had to read it a couple times. So let's verify how many. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 15. So this would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so it's the number 10 because 0 was here. So 10, 11, 12, 13. So in this case, they're both 14. It's technically the 15th element, if you will, right? If we were considering length. But anyway, 14 is the number. So this is basically the same as the other one that I just showed you. And but now flipping the code a little bit to get the largest number rather than the smallest. Okay, yeah, you definitely use loops for these things, and of course with arrays. All right. Okay, so that's the first three. They're all pretty easy. Well, the second and third one for sure are. The first one may be a little bit harder, but I'm sure it'll be okay. So let's see number 4. Because I haven't decided what videos what creations I'm gonna do in terms of programs. All right, so here, write a program that reads a file. Okay, so file. So that means we're using an in file again. Yeah, this is a text file. Okay, so we're gonna have a text file here. So note up here, guys, text file. So it reads a file consisting of students' test scores, which means I'll probably demonstrate something probably like this. I can't say that for sure yet. It depends on what I see in the chapter out of their examples, if they're giving enough to you or not. But either way, I'm only going to obviously demonstrate a couple things, and you have to read. Remember, read your ebook, read the summary of the ebook, read the terms, key terms in the ebook, and look at the darn pictures. Anytime they say example, they're giving you some good important code information. All right, so anyway, and why it doesn't go to 0 to 100. So the test scores are kind of bizarre. They go up to 200. Should then determine the number of students having scores in each of the following. Okay, maybe because they want more ranges. So they basically want to find out how many students made between a 0 and a 24 out of all these numbers. So let's see. So 0 to 24. Here's 1 after the 76. So the number 12 is 1. 1. There's only 1. Still only 1. There's only 1. Okay. So 25 to 49. I'll only do this one here, the next one. So 25 to 49. So 25 to 49. So that would not be 12 anymore. So 25 to 49. All right. So 28 is 1. 28. 25 to 49. 35 is 2. So there's 2. I'm not going to, whatever. But so you're looking at this. Obviously, again, the reason we're using arrays is so that you can get all these values, but only have to have one variable name for them. And then the rest of the name is going to be what we call the index. And again, I'm going to demonstrate this in class. So, I mean, as in my next video. But I may also demonstrate it from one of the examples in the book, depending on what the PowerPoint slides show us. All right. Okay. So then you're going to do that. And remember also, just click here and then test your little output. So they're saying you got a 0, man. Run the checks. Hopefully it'll tell me why I got a 0. 0 out of 1 check. So let's click this thing here and see what it says. Okay, so they're saying 0 through 24, yeah, there should be 1. 25 through 49, there should be 2. And then because that's the 2 I looked at. So a bunch of people in the 175 to 200. Quite a few in the 150 to 174, et cetera, et cetera. Okay. All right. So, and then you can look at the details, I guess, and figure out what it is. But that's what they're saying that's the expected output. So if you verify and you're using your, either switch structure with case statements or if statement logic, for these, it might be better to do switch structure with case statements because you have these values all built in. But either way, it's up to you. All right. So get out of that one. So that was 8-4. Okay. So 8-4, 8-5. 8-5, 8-5. So write a program that prompts the user to input a string. Yeah, so again, chapter 8 is arrays, but it more string manipulation, I guess. So it prompts the user to input a string and outputs the string in upper. Prompts the user to input a string and outputs the string in uppercase letters. We definitely. Well, okay, they're saying use a character array. That's what they call C strings. Okay, I never use C strings. Okay. All right, well, I assume there'll be an example in the book, and they're pretty easy. So, okay, all right, so that's fine. But that one, you're going to be using C strings. Okay, C strings. I'm going to try to remember that when I come to it in the book. All right, 8-5. And 8-6, start. I've already been here now, probably a bit long, but I'm not going to make this a long video either way. It's going to be a relatively short one. All right, history teacher at your school needs help in grading a true-false test. There's going to be another. Okay, so there's another data file. Well, since there's 2 using data files, I'll probably make an example for sure using a data file. So that'll be a foregone conclusion now, if I remember that. So you guys will remind me of this when you see this part in class more. Okay, so I'm not going to read the rest of that one now. I'll just come down here. So we know there's 2 that are using, we're using a smallest number, a largest number, a C string, which is a character string, and data input files, 2 data input files. I'm not going to say what the data input files have. That'll make it too hard for me to remember. Okay, so that. All right, so I'm now going to get out of Mind Tap. I think I don't need that anymore. Oh, actually, I meant to show you where you're at. Because, so remember that officially, here's, if you can hopefully see my calendar on the right side. So this is going to be the 22nd of November. So that's 1 day, okay? And once class starts tomorrow, then I say the day's over. So tomorrow's over, once tomorrow begins. So it's gone. 24th is a holiday, so it's gone. So after the 24th, we got the 29th and the 1st. So that's 2 more class days. And then the 6th and the 8th, that's 4 more class days. And then the next day, the 13th, is the final exam. So you only have 4 class days to go, once the 22nd of November ends. All right. Okay. And the exam is going to be on the 13th. And by the way, that will start at exactly the minute class starts. And I'll give you probably an hour and 40 minutes. That's, I think, the norm these days. So it'll be 100 minutes. But listen to this part, because officially, when class ends, it ends in week 16. Week 16 is Thursday, December the 8th is technically your last class day. Okay. I believe I set the programs up so that you have until the 9th to finish them. The 9th. Do not send me an email on the 10th or even on the 9th or the 8th saying, Professor, I've never bothered you all term and I've never submitted anything late, but please, I need to submit this late. I'll say, no. And by the way, I do know it's student, feedbacks. So you guys get to do all the feedback on Professor Maloney that you like. Also, all the feedback that you don't like. It's up to you. But hopefully everyone in this class knows where you stand. I've definitely shown you. You go to your My Grades link. You're not only going to see all your grades, but you're going to see an average for your exams. You're going to see an average for your programming exercises. You're going to see an average for your quizzes. You're going to see your bio post. And my syllabus clearly states exams are 60% of your class weight. So that's 60. Programming exercises are 30%. So that's 30 and 60 is 90. The quizzes, there's 8 of them. And I said that's 8%. So 90 plus 8 is 98. The bio post is 2. 98 plus 2 is 100. So you know how you stand. And I've talked to several of you that I even suggested you should drop. I mean, I don't want anyone to fail my class, but if somebody is struggling in it, I'd rather them get a W by withdrawing on time as opposed to an F, But in any event, so it is student feedback time. So I'm letting you know, you can beat me up all the heck you want. That's your right. I think I do a pretty good job. I think I'm very clear. Well, I'm not very clear actually, but I mean, I try to be clear. I give you guys videos. I do everything I can for you. But bottom line anyway is, why am I saying that? Oh yeah, so I'm reminding you where we're at. You can no longer submit late work. Did I allow you to submit programming exercises, chapters 2 and 3 late? Yes, I did. I let you submit them up to 1 week late with a 20% penalty, but I let you submit them late. So if you were behind, you had every opportunity to submit them. Did I let you submit chapters 4, 5, and 6 programming exercises? Yes, I did. You had every opportunity up to 1 full week to submit them with a 20% penalty. Will I let you submit programming exercises from chapter 7 and chapter 8 late? No, I will not. Why? Because class ends on Thursday, December the 8th, and I'm giving you 1 little day. That's all. So I'm not going to count that as anything, but I'm giving you till the 9th of December to submit those programming exercises. Then the next week is called finals week. That's why there's no homework can be submitted. No grades can be done other than your exam on finals week. All right. All right. Now I really got to get going. We're just going crazy, but not hitting what I want to hit. Okay. So that's all that stuff there. And if you need to see these dates, obviously just go back over to Student Start here and look. But I don't want to see how many of you have not done anything yet. It might disappoint me. I hope most of you have done things. Let's face it also, since chapter 4, I gave you guys at least 2 student challenges in chapter 4, 2 in chapter 5, 2 in chapter 6. And then in chapter 7, I sort of moved away from giving you student challenges to basically giving you most of the code on 2 programs. And in chapter 7, there's only 5 programs. So I gave you a lot of the code in 2 of the 5. And in chapter 8, I'm trying to not give you anything other than enough code to help you figure it out, but without me going over and telling you 10 different times what you need to do. So, but either way, I believe I've been more than fair is my point. Okay. Hopefully, everybody, I for sure have said in this class that if you send me an email, I might reply before you even hit the send button. I mean, I'm that type. If any of you want to check your emails to see how long it took to get an email reply from me, check, right? So I'm just basically saying I think that I did a pretty good job, which means I hope I get good reviews from you guys, but that's up to you. Anyway, here we go. Finally. So now PowerPoint, all right? So I got PowerPoint up. Now this time I'm not going to do what I normally do. Here's chapter 8. Normally I spend 10 minutes on, let's say if they're all objectives, 1 of 3, pretend, okay? 10 minutes here, 10 or 15 minutes here, 10 or 15 minutes here. And then I finally get down here and I say, well, but I sort of talked about it. Well, I sort of talked about it this time because I don't have the time right now to go through all these things, but you need to look at your ebook. So I'm just going to start here on what they're calling the introduction, which is after the objectives. Okay. So you look at the objectives, you read the ebook. There are 58 slides here. So out of the 58, I'll be hopefully getting through quite a few of these today, but without having started at the objectives. So this is slide 5, okay? Slide 5. So there are 2 data types, basically. Simple data types we talked about, through the whole term, and that's what we were using the whole term. Now we're using structured data types. They're used very, 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 very frequently with arrays, right? So what is a structured data type? It's a data type in which each data item is a collection of other data items. So as an example, when we're doing, when I was going through the e-book, in my case, the physical book, I noticed that they had done, there was a test scores example, and they revisited the example from, I think it was chapter 4, may have been chapter 5, but I think it was chapter 4. Yeah, it was 4 because we used a lot of variables like test 0, test 1, test 2. Now we probably use test 1, test 2, test 3, test 4, test 5. And I told you that when we then started chapter 5, we could do that, but with just one variable called test. Okay, and capture test and move it over to a total score or some such thing, and then capture all 5 that way. But we wouldn't have a variable for those, with 4 of the 5 anyway, because we'd just be reusing the same number, the same name, but adding it to a total. Okay. In the case of arrays, when we declare a variable with an array has a left square, a left bracket and a right bracket around it. So like if we had for those tests or those scores, instead, let's say we had score, left bracket, 5, right bracket, then what that does, and of course we'd call it int or double. So let's pretend it's double. I don't remember what we did in chapter 4 or 5, but we'll say double score, left bracket, 5, right bracket. What that does is it creates a variable called score, but score has score 0, score 1, score 2, score 3, and score 4 built in. Okay, so we have, with just the one variable score, automatically we have score 0, score 1, score 2, score 3, score 4, as long as, of course, we code the program correctly. All right, and that's a huge, huge, huge thing, because when I did the scores from chapter 4, with if statement logic, okay, and I may have also shown that they probably demonstrated it using switch structure as well, but either way, it required 5 variables for sure, just for the scores. Okay, then I mentioned in chapter 5 when I did the same thing, I believe, as another example, said that with loops you don't need to have all the variables, because of course we're accessing the data. It ends up being in effect like a 0, 1, 2, 3, 4, but we weren't capturing each individual score and saving it. What we were doing was capturing the score, moving it over to a total for score, okay, and then moving to the next number, because it was a loop. So go back to the top of the loop. Let's say it got score, the first score, 90, second score, 80, third score, 100, fourth score, 40, fifth score, 100. And then it throws all 5 of those scores into, let's say, a total score. I mean, we did with our code, of course, but then we didn't keep the individual test scores as variables. Well, now we're in chapter 8, and perhaps I'll also try to show you a little example doing the scores, but with an array. It's not necessary. It's not a big deal per se, but it's what arrays are all about. Okay, and in this case, though, you declare the one variable, but it literally has, if it was 10, let's say it was scores 10 or score 10, whatever, then you'd have score 0 all the way through score 9. And anytime you want to refer to them, normally we do it through a loop, but we use the name of the array in the loop and then the index value from the loop starting at 0. So then think about it. If it's score, and then an open bracket, left bracket that is, and a right bracket, and I put the word index between the bracket, and index starts at 0, but as it's looping, think score 0, score 1, score 2, score 3, score 4. But in the case of an array, all the values are there. They're kept, even though I would still need to move them to a total variable as well. But my point is then you can access all that data. So it's a data type in which each data item is a collection of other data items, and it's huge. Why is that important? Because normally we're using arrays with thousands, tens of thousands, hundreds of thousands of items. Okay, just tons of items. So anyway, that's that. All right, so that was 5, 6. Oh, why am I doing it this way? Sorry, let me get my F5. So I'm on 6. Okay. So that. That's 6. Yeah, 6. Okay, so an array. It's a collection of a fixed number of components, all of the same data type. So I mentioned that one with the score. I said maybe double, because some scores, especially when they're auto captured and stuff, or if there's odd numbers, that's each question may be worth 3.33 points or some such thing, right? So it's good to use them normally as double. But in any event, so it's a collection of a fixed number of components, all of the same data type. One-dimensional array is components arranged in what we call a list form. Okay, so in other words, it's just like one column up and down as a list. So as you're entering things, just think of hitting a number, entering it, hitting a number, entering it, hitting another, entering something else, enter something else, hit the enter key, etc., until you run out of the items. That's a one-dimensional array. Okay, there's also, though, a two-dimensional array. I'll go ahead and mention it now just in case I don't get to it before I run out of slides, or actually it will be in the slides. It's just whether I have to stop based on how long I'm going. So a two-dimensional array is like columns and rows. I always like to compare a two-dimensional array as in the old days. You guys won't know, but your parents might remember. You could buy a road atlas, and at the last 2 or 3 pages of a road atlas, it was like a series of maps. At the end of the road atlas, meaning toward the end of that atlas, meaning it's just like a paper book, but toward the end of it, you'd see things like you'd see a column, so column going up and down, and a row going left to right, and the same cities that are in the column going top to bottom on the left side are the same cities going left to right on the top. And then the two-dimensional array is just a whole bunch of numbers in between. So as an example, let's say Miami is a city that's in an atlas of other cities, okay? And let's say Toronto is. So there will be a column that has the word Toronto, and it'll have a whole bunch of miles under it or left to right on it, depending on where it is in the atlas. And then Miami will also have a column and a row for its values. But they're also, so what happens is Toronto there is a distance, like how far is it from Toronto to Miami? It's more or less 1,440 miles. I mean, I'm not looking at an atlas, but I've done it quite a few times, and it's about that, 1,440 miles. So if you're on the Toronto column going up and down, where it has a number 1440, let's say it'd be about halfway down because it'd be M for Miami, then there'd be a row, Miami, that intersects with the column Toronto, and the number there would be 1,440. Okay, so that's like a two-dimensional array. All right, and the values, the int expression in this case, they have to evaluate to a positive number. Okay, positive integer. All right, have to. All right. All right, so accessing array components. So this is talking about now we create an array, and we're going to talk about the different elements of the array. So the general syntax is a name. You need to have a name for your array. And then you need to have an index expression, again, that evaluates to a positive integer. All right. So the index expression is just the index, just like we had indexes with for loops and while loops and do while loops. Okay. So it's just an expression. But in this case, because arrays can have so many items, the expression is much, much more commonly used, and it's very, very important to get an understanding of it. All right. So in the case of when I mentioned scores a little while ago, so pretend it's double scores left bracket, and then in here 10 right bracket. Okay. So what this thing would do is tie in with a loop where I would use the name of the array, scores, and then instead of the left bracket, right bracket index expression, if it's in a for loop or a while loop, normally we're going to use index, right? So index is the common. And it's going to cycle through all the values, and we're going to be doing it with C input statements. But remember, I also saw when I looked at programming exercises 8.1 through 8.6 a little while ago, that there's a whole bunch of, well, not a whole bunch, but there are 2 of them that are using data files. Now, we've used data files way back to, I believe it was chapter 4, but in all honesty, it may even have been chapter 3. But either way, I will be demonstrating a data file for you, okay? With an array. Okay, so anyway, the index expression with a non-negative integer value. So again, it's going to start at 0, and then it's going to go up to a value, and then that'll be our little array set of set of position values. The value of the index is the position of the item in the array. Array index always starts at 0, and you need to have left bracket, right bracket. You note that's in bold. Array subscripting operator. Okay. So if we had scores as the array name, double, usually you do have the data type too. You can have the double data type. So double scores, left bracket 10, right bracket. The indexes are from 0 through 9, but it would be with the array name. So scores 0, scores 1, scores 2. I'd probably use single because singular, like score, because score 0, score 1, score 2, score 3, etc. Right? Value of the index. So the value now is the position of the item in the array. So the index is the array, is the index 0, 1, 2, 3, 4, 5. But we're going to tie it in with score. So where scores come into play, score 1 would be the second score entered. So score 1 would be the index, okay, the second index, because remember it starts at 0, but it would have a value. Under it, we could have like CIN, greater, score, left bracket, right bracket, and then index, because it's going to be in a loop going from 0 to 1 to 2. In other words, we're going to say enter 10 test scores. And then under that, it'll say CIN, obviously, greater, score, if that's the name of it. And then in the brackets, just the index, because this is going to be done in a loop. So it'll be our loop, right? But it's using the array by having left bracket and right bracket. Okay, so that always starts at 0. That's all good. All right, good. So this statement declares an array of 10 components. So int, so yeah, remember I mentioned you have your data type, obviously. So int list 10. And, arrays do have semicolon at the end. It's just a regular code line. So, but again, get used to the left bracket, right bracket. So then what this translates to, okay, is list. That's the array. So then if you're using this for loop or this while loop, I'm pretending this is a loop, for loop, while loop, do while loop, whatever loop, then what you have is where list 0 is up here on top, the user, or we're going to get from a data, from a data file, scores. So if the first score is a 90, the next score is a 80, the next score is a 90, the next score is 100, etc. Right? Then we have a list index. So this is the index. And then the value for the index would be the numeric score. All righty? All right. And they're saying you can, this little thing here is also how you can assign a value. So here, list 5. So if you have this is all representative of this variable here. So the array, list 10. So list 5 means the 5th element in that particular list. So if you're basing it on the fact that 0 is the first, so it's 0, 1, 2, 3, 4, 5. So position-wise, it's the 6th index, okay? And they're again showing you list, name of the array, list 0 through list 9 as the elements of the array. And in this case, because we are assigning it, you'd never do this, of course, but this is what they like to demonstrate things in a silly fashion sometimes, but that's okay. So list 5 means it's the number 5, yes, but it starts at 0, so it's the 6th position or the 6th index, and you assign 34 to it, right? Okay. Now, list 3 is 10, fine. List 6 equals 35, fine. Again, where 3 is the 4th value, 6 is the 7th value, and this is, they're showing you basically that you can add values, but you can only add these values up, first of all, if you've got something in it. And why would you have something in list 6 when it's being added into a total for list 5? I mean, unless, of course, you got all these, and maybe that's what they're saying. You're really having all of these, but they're showing that list 5 is going to be comprised of list 3 plus list 6, okay? And if that's what they're saying, then fine. You can say list 5 equals list 3 plus list 6. That would be okay. All right, so that. So one-dimensional arrays, that's what we're going to be doing for the most part. If there's a two-dimensional array in chapter 6, chapter 8 programming exercises, if I'm doing an example to demonstrate, one-dimensional, and I said there'd be at least a couple things that example this time is going to show. So rather than making it largest or smallest, I'll just make one with 4 or 5 different things, and I'll include a largest or biggest or smallest or littlest or whatever, but just as part of it, and then let you guys go looking, right, to find what you need out of that. And I'll try not to over talk about it. Anyway, all right, so each operation, So basic operations on a one-dimensional array. Obviously, you initialize the array, you input data into the array, you output data stored in the array, and you can find largest and or smallest elements if you want. You can also just search for any given element. It doesn't have to be largest and or smallest. Okay. Each operation requires the ability to step through elements of the array, which of course we do with loops. Okay. So now another little declaration: int list 100. And then int I for accessing those items. So look, right away, you see that we're using a for loop, right? And you guys know for loop. And that's one good thing about this. I mean, you at least understand it a little bit. And same with while loops. But look at here. So we declared an array. That's the important thing to note. It's got the left and right brackets. The list 100 means you have 100 elements. Literally, they're all called. There's literally 100 variables with that one variable declaration. One array declaration. You have list left bracket 0 right bracket, list 1 list left bracket 1 right bracket, and then etc to list left bracket 99 right bracket. You have 100. Okay, now what's the for loop doing? Well, you did for loops. So I equals 0, I less than 100, I plus plus. So that's what we're starting with, 0. Where we're going to, the max we can go to is less than 100. Why? Because it's 100, but it starts at 0. So that means less than 100 is 99. So that's perfect. And then we increment the array with the plus plus. So that's perfect. But then look at this. See, we're taking it from the user in this case, right? And where are we putting it? Rather than just have it assigned to these variables here, it's in the array. So if we're using the array and we want to put all the responses from the user into the array, it's the variable name for the array, list, and then you got to have the left and right bracket. And then here, just I, because we're using I here. If it was index equals 0, index less than 100, or counter equals 0, counter less than 100, counter plus plus. Whatever you use in the for expression, which is the open and close parentheses with the stuff in between, then you use that same name down here, right? So very simple. All right, now example 8.3 in the text, which shows how loops are used to process arrays. And this is one I'll probably end up using. Maybe I'll pretty it up a little bit, but I did look at it already, and they show you how to do like the initializing an array part. They show you the same thing with reading data into an array, the same thing with printing an array, the same thing with finding the sum and average of an array, and finding the largest element in an array. So they do it pretty well, but because you're now much more advanced, they don't give you everything anymore. So they're just literally putting the loop here, like we just had this previous page, So they're using, like, they only show this part of it, 3 lines for initializing, for reading data, for printing. Okay, and then I'll sort of throw all their little examples, most likely, into my own little, demonstration for these things: initializing an array, reading data into an array, printing an array to the screen, finding the sum and average of an array, and finding the largest element in an array. I'll do one program that sort of includes all of that stuff. All right. Now, array index out of bounds. So one of the things with indexes, is you got to be careful that you don't get an index out of bounds. So in the case of the previous one more time. So right here, if we have this int list 100, okay, that means, again, we have int list, left bracket 0, right bracket, all the way up to list, left bracket 99, right bracket. So there's 100 elements, but you can't then, if you remember a few before that, let's see, previous, I'm at 11, I'm at about 13. I'm going to go back right here. So in this case here, if you said list 5 equals, and in this case, see, there's a total of 10 elements, right? Index 0, index 9, so there's 10. If you say list 5, which is this, equals list 3, and then plus list 10, that would be an index out of bounds, okay? So your array out of bounds wouldn't work. That's all that I was trying to get at, and that's what they're talking about here. So let's just, actually, I think I can do these just right here, yeah. So that was that, okay? That. So that's index out of bounds, right? So out of bounds. There is no guard officially in C++, but usually if you're decent with your loops now, you're going to know how to prevent it from going higher than it's allowed to go, and of course lower than it's allowed to go. All right. Now, array initialization during declaration. So as always, there's lots of things they offer to us to let us do things. So they're saying here is an example of some sales. So double sales, again, 5, right? 5 means there are 5 values in it. And these, in this case, these are values, but 12.25, remember, is sales 0. 4568 is sales 4, because it's 0, 1, 2, 3, and 4. 5 elements. So sales 0, sales 5, sales 4. Okay. All right. Example 2. The array size is determined by the number of initial values in the braces if the array is declared without size specified. So here they're saying they didn't put in a size, and you can declare a valid array this way. Double sales, as long as you're identifying that it's an array, that means left and right brackets. At some point, you have to assign values. You can get them from data files, commonly done. We're going to be doing most of it probably from C input statements. But again, I'll have most likely one example with using a data file, and I guess creating an out file like we did a few chapters ago, 4 chapters ago or so. Okay, anyway, so in this case, double sales, left and right bracket, empty, but saying equal. 1225, 3250, 1690, 23, and 4568, same values. So in other words, that's 1, 2, 3, 4, and 5 values. So it's the same as having sales. This thing here, up here, is the same as this thing here. And it works the same because here we assign it as an empty array, but there's an equal sign putting the values right next to it. Okay, so you can do it that way. It's perfectly fine. All right. Partial initialization of arrays. So the statement int list 10 equals 0, this will automatically, it's like a shortcut if you want, to automatically initialize all values to 0. Okay, so int list 10, but you notice that instead of brackets here, it's a curly brace and a closing curly brace, and you put 0 in between. What that will do, only because of the curly brace, it'll then put zeros for list 0, list 1, list 2, all the way to list 9. Okay. Statement, an example of partial initialization of an array during declaration. So in this case, they're saying, well, let's declare an array called list. 10 items are in it, and they've got 8, 5, and 12. So they only have list 0, list 1, and list 2. You can actually do that if you want to. Doesn't normally make sense, but 0 would be assigned to the 8. 1 and B, list 0. List 1 and B would be assigned to the 5. List 2 would be assigned to the 12. And then everything else would be initialized to 0, even though it doesn't reflect it up here. Okay? So you can do that stuff, but we're not going to be doing stuff like that, which means you don't need to be doing things like that. All right. Aggregate operation. No, some restrictions. So aggregate operation. Any operation that manipulates the entire array as a single unit. It's not allowed in C++. Okay? So look here. Example. Int mylist5 equals 0481216. That's perfectly fine. Int your list 5 line 2. That's perfectly fine. Your list equals my list is not perfectly fine. Okay, so the first one is a value, an array with 5 items, and all 5 are listed out. Okay, so you can definitely do that. All right, but then in the int your list 5, it's just declaring the value. You don't have to put the your list 0, your list 1, your list 2, 3, and 4 values yet. That is a fine declaration. There's nothing wrong with it. But what they're showing that's wrong is because they do have 2 array names. One is my list and one is your list. You cannot assign an aggregate. An aggregate means all of it. You can't assign your list, or sorry, my list to your list. You can't do that. But there's always a solution, and it's through an array, right? Similar to when we did the enums last chapter. Remember, we could not touch an enum without going into it indirectly through a loop and a variable name. So here we're doing the same thing. We're going in from a loop. So for index 0, index less than 5, index plus plus, the usual for 4, right? Your list index, because we're wanting your list, we want to get my list. So that part is right. Your list index on the left, and then we're taking index on the right. So whatever as we're coming up to the first value for my list index, then the index is assigned to the same index over here. See, this works as long as you're not having different values in your indexes, because the indexes, remember, are always 0 based. So the first value from my list index, which here is 0, would then be assigned to your list 0. The next one, 4, would be assigned to your list. Well, the next one is 1, but with the value 4, would be assigned to your list index position 2, index position 1, sorry, value 4, and then the same with 8, 12, and 16. So that's fine. Okay. All right. Arrays are passed by reference only. You do not need to use the symbol, the ampersand, when declaring an array as a formal parameter in the case of arrays. The size of the array is usually omitted in the array parameter. If provided, it is ignored by the compiler. It just means we're not, at this point, when we're using parameters to functions, and I don't know, actually, I don't know that I saw, technically the in file, the ones that use the in file, one of them anyway, did have formal parameters. So that one, I'll look in the book depending on what it is doing or not doing, and then talk about it a little more if need be. But at this point, all you need to understand is that when you're passing things by reference in an array, it's when you don't need that ampersand. Remember, the ampersand tells us it's a formal parameter, tells us that the value can be copied, meaning the memory address can be copied. So we don't need to worry about it, but don't worry about this until you get to it. So the following example illustrates a function header, which includes an array parameter and a parameter specifying the number of elements in the array. So void, again, void means we're not going to do anything with it outside of the procedure itself. And then, initialize int list. So in this case, the list is an empty array right now, and then the size will represent most likely this list size. That's fine, but it's not really doing anything for us yet. All right, constant arrays as formal parameters. Can prevent a function from changing the actual parameter when passed by reference. This again gets back to the enums. In this chapter, we're not going to, I don't think, do anything with constant integers or constant doubles or constant strings, but just enough to know that a constant means it can't change. So the point of this is just letting you know that you can technically have a constant value for the int y, but look at this, int y in this case has the reference, right? Array reference meaning. So it knows it's an array. So this is letting you know that you can, in fact, carry lots of values over that can't be changed. So if you use the keyword constant as part of that argument list, okay? Base address of an array in computer memory. Base address, you know that, is the address of the first array component. If list is a one-dimensional array, its base address is the address of list 0, because it's from list 0 to list 99. So list 0 is the first address, and that would be the one. When an array is passed as a parameter, the base address of the actual array, and you know that because you know enough about parameters to know the actual address is passed. Excuse me. C++ does not allow functions to return a value of type array. So refer to example 8.6 in the text. I'm not going to go to 8.6 now. It might be or might not be on the next page. So functions, sum array, and index largest element is what I'm going to guess they're going to probably get into on the next slide. And if so, it's here. So C++ allows any integral type to be used as an array index. So because, you know, chapter 7, remember your test is technically your final exam is chapter 7 and chapter 8. And like I said, in the case of chapters 4, 5, and 6 exam, what did it have? Well, it had chapter 4, it had either a switch structure or if statement. I think I gave you your choice. It also had a for loop or a while loop. I gave you your choice. And it had, in the case of chapter 6, a function. It said it'd either be valid, value returning, or void. And I think I told you it would be a value returning. So you knew everything. So here, when I get closer to the talking about the practice exam, and by the way, so remember the practice exam day is 5 days before the real exam, right? And that means it's a Thursday, and it's that Thursday in week 16 that I showed on my little desktop calendar earlier. I think it's December the 8th, okay? So you're going to get your practice exam, and it'll have whatever you need with enums from chapter 7, and of course it'll have whatever you need from arrays from chapter 8 in the practice exam, so that you'll get a feel for how I'm going to code, or you know, what the real exam will do, okay? All right, other ways to declare arrays: constant int number of students equals 20, int test scores number of students. So again, you notice what this thing here is doing, it's pulling in the number of students into test scores. So what is test scores? Test scores is an array. Where are they getting their values? From number of students. Excuse me. So this is quite popular, used all the time. And I think there's an example or two in the chapter illustrating this as well. But that's all it's doing. So the key to remember from the example 1 is that test scores is an array. Why is it an array? It's got a left bracket, it's got a right bracket. And then inside the array, you need to have whatever you're going to be allowing in to be used for it. In this case, it's a constant. So its number of students equals 20. So it never changes. So you can never vary test scores for 21 or 31 or 41. Okay, cannot be done. Constant integer size equals 50. Type def double list size. Remember when we do a type def, we're not officially having the name. Usually we only use type def if we're just going to use something to get a number and then throw it away. So we won't be doing anything with type def for sure. But in this chapter, if there is anything, it would be similar to the example 1 here with test scores, number of students, and then have a variable representing the number of students. And in this case, like I said, it's mainly just because it's a constant. They wanted us to keep it. All right, so searching an array for a specific item. I believe I said programming exercise, not programming exercise, sorry, but programming example. So hopefully at this point, you know that programming example means something in the book. Programming exercise is also in the book, but it's something you're assigned to do. So the programming example, they refer to 8-3. So you can look in the ebook for it, because I said I'm going to definitely illustrate something on it. But anyway, and if you remember, there were about 5 things on it. One was initializing an array. One was searching an array. One was printing an array. One was finding the largest item in the array. And one was, there's one more. Okay. But either way, you know, I'm going to come back to it. So it's A-OK. So they're saying, though, you can also search. So if you're looking for, and actually, you know, in the highest, what was it called? Largest item, I believe they said in that particular 8-3 example. So when you're searching for an item, that's an example actually of searching for a given item. You're looking for the highest value. So if you got values 5, 15, 10. Let's just say 3. So 5, 15, 10. Well, 5 is not the biggest. 10 is not the biggest. The second one, 15, is. So you'd have to set up your loop to compare and assign the first value to another value just to see if it's going to be the biggest or not. And you always start with the first value as the biggest. Or if it was the smallest, it would be the same thing. Then you compare the index for the second one, which would be 1, to the actual value for the second one. So if the first one was 5, the second one was 10, and you're looking for biggest, well, then 10 is bigger than 5. So then 10 would be assigned over to 5 as the search, as the biggest, whatever the variable name we call it, largest item, biggest item, whatever. And then, but the program wouldn't know it was the biggest until it finished going through the others. And I said if there were 3 items, and maybe the third one was 15 or whatever. So that would be done as well. So this I'm going to also be demonstrating. All right, so I'll be demonstrating it in class on the second day of chapter 8, which is going to be 1 week from the 22nd. It'll be the 29th, because the 24th, remember, is Thanksgiving Day. All right, so sorting, selection sort. Rearrange the list by selecting an element and moving it to its proper position. Steps for a selection sort. You can find the smallest element in the unsorted portion of the list. Move it to the top of the unsorted portion by swapping with the element currently there. Start again with the rest of the list. So what this thing is saying is, it's again similar to using the largest item or the smallest item. And in this case, they're saying if you want to then have all the items sorted from small to big, okay, then what I just illustrated there, didn't illustrate, I will illustrate though in class on the 29th, and it'll also illustrate this in effect. But basically, you have to compare every item against every other item. And the first two, remember when I talked about the Fibonacci also, and I said that if you add two numbers up, then those two become the third number. The third number then goes back to being the second, and the first is then disbanded. So in this case, just think of that, where the first and second numbers, one is bigger, one is smaller, right? Well, if you're sorting it, you want to sort it by smaller versus bigger. So you can have it similar to that, and then just have a variable to reflect what the current value is on the list, and you keep going. And I'm sure it's in the book as well. And it'd be after 8-3, since I already talked about 8-3. Selection sort. And now they're going to demonstrate it a little bit better. So on sorted lists, we have, this is just like us entering numbers, okay? And then they're saying, so they're looking, they found the smallest index. And if they want the smallest then to be the first, then they're going to then swap. They're saying, so swap 5 with 16. So when you find out the index value, so the index here is 0. The index here is 0, 1, 2, 3, 4, 5, 6. So you'd assign, let's just call this list 6 with list 0, okay? And then you're then going to though have, so 0 is now there, but then you're going to be looking for what? I don't know why they're even saying this one this way either way, but if you're going sequentially in order, then you're going to be looking for the 7, and then put the 7 where the 30 is, right? So you're going to be doing all that. And then elements of the list. Yeah, okay, this is just the first iteration, right? So then it's going to go through iteration. So obviously then it'd be 7 again behind 5. After that, it would be 16, 24, and let's see if the next slide shows it. It's not. So that means they're probably not going to really be doing much with it. But it's again similar to finding the smallest, similar to finding the largest, because all you're doing when you find something, you can then move it or not, right? In the case of what I'm going to be doing, it's going to be just getting the value from these indexes, comparing the values from the indexes to figure out if we got the bigger number or the smaller number. So what I'm going to be basically doing, just putting it that way for now. So let's pretend this is not saying smallest, but it's the same style. So if these are our numbers, okay, we're inputting numbers and we're looking for the largest. All right, we're going to make this first. So we're going to first of all say like we got a max biggest or some such index. All right, max index, and we're going to assign it to 0. So max index equals 0. Then we're going to take the list index from what this one is, and list 0 here, it'd be going up against max 0. So max 0 is always going to be, initially it's a 0. So list 0 is bigger than max. So then you assign list 0 to max index. So now max index, instead of being a 0 for value, it's now going to be a 16. So then it's this one. So then list 1, right? That was list 0. So now list 1 will be compared to max index. Max index is now 16. 30 is bigger. So then because it's bigger, 30 will then go to max index. So now max index is 30, and we'd be coming up to 24. Well, 24 is not bigger than 30, so it'll stay 30. 7 is not bigger, it'll stay. 62 will be compared then to max 30. So in other words, this logic, what I'm just demonstrating, is the same as for doing it on smallest. And then there again, going back to just say this one iteration. But if you're doing your sort and then you're wanting to sort a list the same way, so what you're going to be looking for is once you find the smallest element, then you're going to want to put it first. Then you're going to be looking for the next smallest. So then if you find the next smallest, you're going to put it, this would be 0, then 1, then 2, 3, 4, etc. So I know it may not make a lot of sense, but it's the same logic. And again, you have to do some things, obviously, but please read it in the book. But it is A-OK, and it's very similar to the biggest number or the smallest number. Auto declaration and range-based for loops. So C++ allows auto declaration of variables. Data type does not need to be specified. So they're saying in this case, auto num equals 15. Well, 15 implies an integer. We're not going to be using that. Don't worry about it. Range-based for loops. So double list 25, double sum. Sum equals 0 for double num, colon list, read as for each num in the list. So what this basically means is it's going to read all 25 of these values, okay? And then sum equals sum plus num. So what it just does is allow you to use a for loop with what seems to be only one argument, but you need to understand that if you're good with it, then you can do that. Otherwise, please continue to do it the way we've done it, which would be we would have our num equals 0, semicolon, num less than list, in this case 25, so just num less than 25, semicolon, num plus plus. That's what I want you to do. But that's what this is saying. So range-based for loop eliminates a little bit of the expression in the loop, but it makes it more confusing. Okay, so that's that one. Character array is an array whose components are of type char. But they're usually C strings is what we usually use them with and call them. So character array is an array whose components are of type char. C strings are null terminated. Null terminated means you got this single quote \0, and the single \0 is going to be something that there's nothing there. It's like hitting the space bar. Okay, so the space bar, which in the ASCII world, by the way, is actually a 32, so it'd be a 0, 0, 0, 1, and then 5 more zeros. But the way we do it in C++ for using that thing, anytime we're wanting to deal with something that's null, meaning empty, it's a single, it's an apostrophe, \0 apostrophe. Okay, so example, a single quote is the character A, double quote A is the C string A. So the C string is the string version of taking the same thing with the character. We're going to be, I think I said there was one example of this, and I'd look in the book to see what kind of example they give you. So I'll look at this and see if I think it gives you enough information to help you out, but I think it probably will because it's not really that much. Okay, so note A as a string represents 2 characters, the A and the single quote \0 single quote. And the reason it does that is because you don't have nulls with strings. You have nulls with the char. Okay. All right. So C string character array. This is an example of a C string declaration. So char name 16. Since C strings are null terminated and name has 16 components, the largest string it can store has 15 characters. If you store a string whose length is less than the array size, the last components are unused. Read this and we'll see if we need to talk about it later. But again, I don't think so because you're not going to be doing that much with the character arrays. There is a programming exercise I think I read quickly when we were at the beginning of class today, or this video, but it's not going to be doing much. So don't worry too much about it. Size of an array can be omitted if the array is initialized during declaration. So the same thing here, just saying that. So the length in this case is going to be the length for John, but it's going to have C string John. So that means the array is going to be of length 5 because it's got the null. So it's got null plus J plus O plus H plus N. Okay. Useful string manipulation functions include. So we may or may not be doing string manipulation again in this chapter. I did say, actually, it did say strings and arrays. So for sure there's some. You know, the string CPY is copy. String CMP is compare. String LEN is string length. And the string with N copy is another version of copy. I don't remember what the N is, but it's okay. Obviously, if it matters, it'll come on one of the next few slides. Otherwise, if it matters, it'll be in the book. But string copy, string compare, and string length. And you've used string length. You've used, well, we've done compare, but not comparing it by itself. We've done it ourselves manually. And we have not used string copy. C strings are compared character by character, and we know that, using the collating sequence of the system. So use the function string compare if using the ASCII character set. Ir is less than both. And remember, the ASCII just means A is less than B. So therefore, A is less than that. Ir less than both is okay. Ir is less than un. It'd be the same thing. The AI is less than the N. So that's okay. Bill is less than Billy, because the Y is at the end here. Hello is less than hello. And in this case, that's true too, because the capital H comes before a little h. Okay, don't worry too much about these either, but I mean, that's what they're doing. Most rules for arrays also apply to C strings, which are character arrays. Aggregate operations such as assignment and comparison are not allowed on arrays, right? C++ does not allow aggregate operations for the input and output of C strings. String input, again, we'll just look a little bit, but if I want to keep going, I'm going to actually, I wrote down when I started here, and I'm trying to see, let's see, it said, no, I can't see that. Can't see after I write. I can't see. Let's see. 4:22. All right, so what time is it now? Where's my watch? Wait a minute. I hope this is not right. If it's over an hour, I'm going to go ahead and stop this thing. But I'll go a couple more slides. You know what? It's 32. I'll continue with what we normally do in my programming exercises to demonstrate the rest. Because, again, it's hard to go through all these things. But let's just look at this one with string input. So string CIN name find. So C string in the name. Read strings with blanks. Use the get. So remember, get, similar to get line. The get line we used when we were needing to use a value, and we want it to purposefully get an entire line. So it comes from the get. So you've used get at least as part of it with sin.getLine. So when executed, the statement stores the next m characters into string, but the new line character is not stored. New line is not stored probably because it's not get line. Okay. So that's what's happening here. If input string has fewer than m characters, reading stops at the new line character. So if this matters on your exam, I will get to it. If not, I won't. String output, outputs the name to the string, can you write the name, so finds a null character. So I guess what they're just trying to emphasize is that the null character, remember that's like the space bar, there's nothing there, or the single apostrophe \0. Okay. All right, so I'm going to now stop. Hopefully this is going to be enough for now. And on Tuesday the 29th, though, I'm going to move on to demonstrate a couple examples of things you'll definitely need in your programming exercises, okay? But please review the rest of the slides just to have that out there and at least know where they are. There's 58 slides. I'm only on 34, so there's really another 24. Now, it doesn't mean it's all going to be this. It's just, you know, whatever they're going to be doing. We haven't even gotten actually to the two-dimensional arrays. So I'll maybe go to the two-dimensional array just to see where that is and talk about those for a little bit. So parallel arrays, two arrays are called parallel if the corresponding components hold related information. So, you know, you can do that with this, but more importantly is two-dimensional arrays, but this is pretty good. So, and here's the two and multi-dimensional. So really there were only 3 or 4 slides on strings anyway. So let me just talk about two-dimensional just for a moment. I mentioned the road atlas, right? So what is it? Two-dimensional array collection of a fixed number of components of the same type arranged in 2 dimensions. One dimension is a column and the other dimension is a row. It goes row column in terms of the order of the two arguments, all right? sometimes called matrices or tables. So declaration syntax, data type. So, int, road, atlas, expression 1 would be, let's call it row, and expression 2, let's call it column. And that would basically mean we're looking for where the row number meets the column number, and we would put out some variable values for what we're doing. So here, syntax to access a component in a two-dimensional array. So your array name, you've got your first argument and your second. We're index exp1, index exp2. They're expressions with positive, got to have positive integer values. So sales5.3 equals this. So again, it would be where, in this case, I mentioned the row and the column, so they're now bringing it up. So row 5, where it matches column 3, there's a price element there of 25.75. Okay, so that's what that would mean. And that's, like I said, it's pretty good. But two-dimensional arrays are big, so it's, especially if you're in an advanced class. So you see here, and in the case of cities, so you can have this word city, and then let's say what's an A city. Atlanta. Okay, I'm going to be going up and down. So instead of 0, Atlanta, Boston, Chicago, Dallas. Let's do some in Canada. Dallas. Then let's get to M, Montreal, O, Ottawa, T, Toronto. So as we're going up and down, and Miami, so we'll have Miami. So then those same cities will be going from left to right. And where 3 here matches 3 here. Okay, I know theirs is sales5.3, but where the 3 hits the 3 here, this 3 here, it'd be the same city as this 3 here, and therefore it would be 0 right there, meaning miles. So as an example, again, let's just say 0 and 0 for one city. So Atlanta here, Atlanta would also be here. So here will be 0. Okay, but here Atlanta to the next city, let's say Boston, maybe 700 miles. Okay, so that then means Boston, which would be the second over here, if it's the second up there. So Boston, and here Atlanta 0, so it'd be the same number, 7, whatever I just said. Okay, so that's how these work. They're pretty good, and they're real good, actually. I mean, they're huge in the world. So we'll leave it here. I'm going to stop, and I'll see you in class on Tuesday, the 22nd. All right, so have a great day. Oh, let me see where the heck I am now. Where am I? That. Oh, I'm in here. Okay, so I'm going to stop my thing now. Stop my recording.